let's look at simplifying radicals. Now, let's go over a few definitions first. The first definition is a radical sign. This is the square root symbol, indicating the principal or non-negative root of an expression. So basically the positive root of an expression. Now, a radicand is the expression under the radical sign. So it may be a number, an operation, or maybe a number and a variable. A radical expression is an expression basically that contains a radical sign. Now, with the radical expression, it's going to be in its simplest form when three things have to happen. The first one, no radicands have perfect square factors other than 1, meaning 4. If it has a factor of 4, it's not simplified all the way. If it has a factor of 16 or maybe 25, it's not going to be simplified all the way, and it can go further. The second one is that no radicands can contain fractions. So you have to get rid of any of the fractions that you see in the radicand. And then the last one is no radicals appear in the denominator of a fraction. So this is going to be that bottom part of a fraction. If there's a radical sign in that bottom part, you'll need to get rid of it by doing a few operations before you can move on and say that your expression's in simplest form. Alright, the product property of square roots. Now, we will use this property in order to simplify radicals. What it's saying is for any number A and B, let's say A and B are any number greater than 0, both of them, or equal to 0. So any number that we're going to call a whole number, which is 0 and counting numbers. So if you've got under the radical sign A times B, then you can basically split these two up. So it's the square root of A times the square root of B. Alright, so we're going to use prime factorization that you learned back in elementary school and the product property of square roots that you just learned up here to use to simplify the radicals. So for example, I've given you the square root of 18. Now the first thing we need to do is break it down to its prime factorization. When you do that, you get 2 times 3 times 3, because 2 times 3 is 6, times 3 is 18. So that's equaling 18. Now we need to split it up. What I'm trying to do is to pair numbers up. So if I have these 2 3's right here, what I need to do is pull them and put them underneath a radical sign by themselves. And then pull any other pairs out as well. Notice the 2's all by itself. There is no more other 2's in this prime factorization. So I'm going to leave it under a radical sign by itself. And then I'm going to pull these 2 3's out and put them underneath the radical sign. Notice everything's being multiplied, so I can kind of manipulate everything. Now, I can do this because of the product property of square roots. Now, if you do 3 times 3, okay, we get 9. And basically what we've done is done our operation to realize that we have a perfect square. So I get here because of the remaining perfect squares. Now, I can take the square root of 9, which is 3. So this is basically our solution, the square root of 2 times 3. But we don't write it that way. How we need to write it is put this number in front of your radical sign. So I'm going to have it as 3 times the square root of 2. So this down here is going to be my final answer when I'm asked to simplify my radical. So let's look at a few examples. Now, these I basically need to simplify the radicals. Same thing that I did with the square root of 18. With the square root of 147, I know it's a big number, but you do need to work on, let's take out some prime factorization. Okay, basically take out and make it to where it's only multiplied by those prime numbers. Now, I know 3 goes into here, and I know 7 goes into here. So what I need to do is pull it all out, and when you pull it out, you get 3 times 7 times 7. Okay, that's going to give you 147. Now, if you notice, I have a pair of 7's here, which will make a perfect square. So I put those two together and put it multiplying, which is 49. And then this 3 doesn't have another pair, so I leave it underneath the radical sign. Then I just simplified the square root of 49, which is 7, put that in front of the square root of 3, and I've actually gotten my simplified answer as 7 times the square root of 3. Alright, let's look at the square root of 605. Okay, when I do the prime factorization, I'm going to get 5 times 11 times 11. Notice you've got two 11s right here. So 11 times 11, or 11 squared, is 121. That's a perfect square. That 5 doesn't have another number to go with it to make it a perfect square, so we leave it under the radical sign. I do the square root of 121, which is 11, so I put that on the outside of the square root of 5. So we get my answer of 11 times the square root of 5. Now this last one, we've got the square root of 75. Now 5 goes into that, so I'm going to divide 5 out, and then I've got 25, if you divide 5 out, you're going to get 15, and then you divide that out, and when you get down to it, your prime factorization is going to be 3 times 5 times 5. Now, the 5 times 5 makes a perfect square of 25. So I'm going to put those two together and then leave the 3 under the radical as well. So I've split it up using my product property of square roots. Now the square root of 3 is not a perfect square root, so I leave it as the square root of 3. The square root of 25 is a perfect square, so I take that, that's 5, and I put it on the outside of the radical sign. So my answer is 5 times the square root of 3. Now I want to use the product properties in order to solve these two expressions. These are getting a little more harder, but basically remember I said the square root of AB is the same thing as the square root of A times the square root of B. Well, pretend this is the square root of A and this is the square root of B. Since they're being multiplied together, I can just do 5 times 35 and then simplify it that way. Another way you can do, which I've showed you, is basically do the prime factorization of each number. So this square root of 5 is prime, so I'm done there. With 35, when I do the prime factorization, I get 5 times 7. Now if you notice, I can actually do and put all of that, 5 times the square root of 5 times 7, like all of that can be put under one radical because we're multiplying it all. But I notice here that I have a 5 here and a 5 here. I can pair them up just like I did in these previous examples to get the square root of 25. Now 7 is left over, but I don't have anything to go with it or to multiply it by to make it a perfect square. So I'm going to leave it as the square root of 7. So I take the square root of 25, which is 5, and the square root of 7 stays the same. So when I simplify this expression, I get 5 times the square root of 7. Now let's do one last one. I have the square root of 6 times the square root of 60. Now, 6 is not prime, so I break it down to get the square root of 2 times 3. And over here with 60, I break it down to get 2 times 2 times 3 times 5. Now if you notice, I have a 2 here and a 2 here. I bring those together to make a perfect square. 2 times 2 is 4. Then I have 2 3s. I bring those together to make a perfect square, which is 9. Now I used 2 of my 2's, so the 2 there, 2 there. I'm left with the 2 here, which I forgot to put, so let's put it back in the back end. All of this needs to be changed. This is what happens when you do it late at night. Mistakes happen, we're not perfect. We'll change all of that. Alright, now I've got a 2 times 2, which gives me 4, so I've got the square root of 4. I've got 3 times 3, which gives me 9, so I've got the square root of 9. And now I've got 5 times 2, which is 10, to give me the square root of 10. Alright, now the square root of 4 is 2, the square root of 9 is 3, and the square root of 10 is not a perfect square, so I'm going to leave it. Now I have these two whole numbers outside of the radical sign, so they're being multiplied together. Everything is. So I can multiply 2 times 3, and 2 times 3 is 6. And then I have to multiply it as well by what's left under my radicand, or my radical, which is the square root of 10. So this is my answer right here. Alright, one last thing. Now when I talked about you couldn't have any fractions, when you're doing this as your radical or your radicand, basically this is how we're going to have to do it in order to get those radicals out. Now, if I look at number 1, 88 over 11, okay, I need to simplify it, and then you take the square root of the whole thing. Now, we said that you cannot have a radicand that's a square root, or a radicand that's a fraction. So what I need to do, since the square root of 88 and the square root of 11 are not perfect squares, I'm going to simplify 88 over 11. Now we know 88 divided by 11 is 8. Now I just have the square root of 8, and I can simplify from there. So when I do the prime factorization, I get 2 times 2 times 2. Now 2 of these 2's can go together to do 4. So I've got the square root of 4 times 2. Now the square root of 4 we know is 2. And then the radical square root of 2 we just leave as the square root of 2. So my answer ends up being from here, the square root of 88 divided by 11, to actually doing 2 times the square root of 2. Now this next one, we've got the square root of 12 over 27. We know 12 and 27 are not perfect squares, so the first thing I need to do is actually to simplify the fraction. If I simplify this fraction, I get 4/9. Well, lucky us, 4 and 9 are perfect squares. So I'm going to take the square root of the 4 and the square root of the 9. Square root of 4 is 2, square root of 9 is 3. So here I have my fraction of 2/3, and I've actually totally simplified and gotten the correct square root for this radical. This last one, the square root of 90 divided by 5. Again, 90 and 5 are not perfect squares, so what I need to do is simplify 90 over 5 first. 5 goes into 90 18 times, so now there goes my fraction. I'm left with a whole number. So I need to find the square root of 18. Do the prime factorization. When I do that, I get 2 times 3 times 3. Now these two 3's back here multiplied together give me 9, and I can do the square root of 9. Now I'm left with the square root of 2 because I cannot make a perfect square out of that. So when I do the square root of 9 times the square root of 2, I simplify it, and it becomes 3 times the square root of 2.